this thing? This thing hadn't been on the road. When was the last time it was out?
Probably like 1988.
Here we come, look at this. 60 miles an hour. Ah, a mile a minute. Welcome to the episode of Jay Leno Garage. Today, one of the more unusual vehicles we featured here. This was built by Briggs Stratton. As you can see, there are 6 wheels. It is a hybrid. I guess it would be a 1980 model, started building it in 78. For those of you perhaps outside the United States not familiar with Briggs & Stratton, one of the oldest engine manufacturers in America, something like 112 years old. Probably most popular or most well known for lawnmower engines, gasoline engines, stationary engines. In fact, the first engine I ever worked on, my dad got me a Briggs & Stratton 2 horsepower single cylinder engine. And I took it apart. My dad wanted me to find out what's wrong with it. You know, I was like 11. I took it apart and I put it back together. I said, Dad, I found out what was wrong with that engine he gave me. He said, what was wrong? He said, there's a piece of paper between the cylinder head and the engine block. And my dad went, no, that's the head gasket. I went, oh, okay. I said, I'm 11. What do you want? You know. So I learned a valuable lesson when I tried to start it. It just came off the side. And I went, okay, now that's what that piece of paper was for. But anyway, a lot of people don't know Briggs & Stratton built an automobile. And this is an early hybrid, which means, of course, gas engine and electric power as well. We have one of the technicians from Briggs & Stratton here, Craig Clairbout. Come in here, Craig. How are you, my friend?
Pretty good.
I say your name right?
Craig Clairbout, yep.
There you go. Very good, very good. You know, I didn't know about this car. I just learned about it. Now, you were involved pretty much since the beginning?
Not from the beginning. That was before me, but I came in at the later end when we still were doing shows with it, using it for promotional stuff. I did the technical work on it towards the end of the last couple of years, the upgrades, changing stuff, maintaining it stuff.
And of course, hybrid technology has changed so much since the 70s. I have a car called an Owens Magnetic over there, which is a gas engine, which powers an electric engine, which powers the wheels. How does this work? The gas, how does it work in conjunction with the electric engine?
This is what's called a parallel drive. So you can drive the vehicle off the gasoline engine, or you can drive it off the electric motor, or off of both, and it's selected by the driver. Some other hybrids use an engine to power a generator, which powers the motor. This is a mechanical connection from the engine to the driveline as well as...
So much like a modern Chevy Volt, you could pull away on electric and go, how many miles? Maybe 8 or 9?
On electric, probably 40 to 60 miles electric.
Even back, okay, and these were lead acid batteries,
yes,
correct? Not, okay, so you could go 40, 60, well, that's pretty interesting.
Yeah.
Okay. I think the most obvious question people have about why 2 wheels in the back. Now, the only driven wheel is the center wheel, correct? And explain why the rears are not driven.
The rear wheels is an additional axle to carry the extra weight of the batteries. So the rest of the car, what you ride in, what you feel, doesn't have the weight of the batteries on that suspension. The batteries are on their own axle, suspended. It's kind of a built-in trailer type concept. I see.
So these tires obviously could not take the weight of the battery.
Right.
Problem. Well, that's interesting because I remember seeing, I think Mercedes had a hybrid, and even Ford had a hybrid about the same time, and they would be pulling a trailer which had a battery pack in it, and then it would have wires coming to the car. That was sort of the idea. Whereas this has the trailer built right in.
Right. Yep.
Well, and the engine is a Briggs & Stratton engine?
Yes, 18 horsepower Briggs & Stratton engine.
Twin cylinder, single?
It's an opposed twin.
Okay.
Air cooled.
Now, was that out of another piece of equipment, stationary engine of some kind, or was it built specifically for this?
No, that engine is what's used in stationary equipment, generators, or garden tractors, lawn and garden. It was basically a pretty stock engine for us.
And I see it has a 4-speed manual transmission. Now, is that a Briggs & Stratton unit, or is that something brought in?
That transmission is out of a Ford, along with like the clutch, some of the driveline pieces. Ford Pinto, actually, the front suspension, steering, those weren't items that we wanted to design and build. We just used parts available to do the concept.
Right. Can we open the hood? Okay. Oh, well, look at that. It's very much like a Panhard, the French car.
Yeah.
Okay, you really can't see the cylinders here, but everything in the air is pulled in through here.
Right.
And blows over the cylinders.
Cylinder heads are down here.
How many cc engine?
It's 42 cubic inches, so a conversion on that I don't have off the top of my head.
Okay, that's about 800.
Yeah, something
cc,
like that.
Something like 8 1/4, something like that. Yeah, all right. Boy, it's very well done. And this is, you guys were doing this really before anybody else was doing it.
Yeah, this was kind of a unique idea. Briggs and Stratton had to get away from using fossil fuels, or less reliance on fossil fuels.
Right.
But electric wasn't totally there yet, so this kind of
Yeah, I remember
things.
electric cars of the period were incredibly slow, and they can only go like 11 miles or something like that, because they were basically just overgrown golf carts. And the top speed was 35 miles an hour, 40 miles an hour, whatever it might be. And that's where the reputation of electric cars being slow and really started. Well, this is fascinating. So was the idea to Briggs and Stratton hope to one day enter the automobile business, or did they want to sell a technology to somebody else, or what?
They never had the intention of going into the automobile business. What they did is they tried to show that cars can be made with smaller engines, and that to try to get closer to our market, our size engines. Cruising on the highway, you only need 14 to 20 horsepower to stay cruising.
Right.
We have engines in that range. This answered the question of how you're going to get up to speed, up to the 55 miles an hour
Right.
national speed limit, and then maintain with the gas engine at that speed.
Yeah, it's fascinating. And tell us about the designer. This was Brooks Stevens.
Brooks Stevens designed the bodywork on it, the design on it.
That must have been one of his last projects, because he was quite an elderly gentleman by that point, right?
He was involved initially with it, and his son Kip was involved. The actual time this design was selected and finished, it was kind of handed over from Brooks to Kip at that time.
Okay. Now, maybe it's my imagination. Do I see parts from other cars on here?
Yeah, you see VW Scirocco doors.
Oh, okay, these are VW doors,
Yep.
okay.
The dash and the windshield are from a Scirocco. The front bonnet and the rear bonnet, the bodywork, that's all custom designed and hand-built by Brooks Stevens.
And the hatch as well?
Yes.
Okay.
Yep, the lights.
So all your batteries are under there. Can we see the batteries?
Certainly.
So how many volt system are we looking at?
72 volt DC. There's 12 6 volt.
Okay,
batteries.
so this is basically, you know, I've got a 1909 Baker Electric over there, and that's 78 volts. Okay, we have our battery pack. We have 12 6-volt batteries here, right?
Correct.
Or what they call deep cycle.
Lead acid batteries.
And
yep.
explain to people why 6 volt is better in this application than 12 volt, because you'd think, oh, 12 volt would be more, but you have more volume here of electricity, so to speak.
Yeah, the goal was to get to 72 volts for the motor. We have 12 of the 6 volts, that gets you to 72 volts. You got a little higher capacity with the 6 volt batteries. It's more of an industrial deep cycle battery, so
Right.
that's the reason for the 6 volt.
So you can force more electricity through the wire of a 6 volt than you can. It's like if you had a garden hose, a 12 volt would be smaller diameter but harder, more powerful. 6 volt would be a thicker hose. You're getting more volume through it. Is that about right? Or am I way off?
The voltage is what pushes it through the cables.
Right.
So if we're at 72 all the time, it's not going to change. The difference is how you get to the 72 volts.
Right.
If you use 12 volt batteries to get to 72, you'd be, in my math here.
Well, you'd have the number of batteries.
Yeah, so you have
But
6
you
of
wouldn't
them.
have the range.
Right, that's the reason for
Right.
more batteries.
So 6 volt gives you more volume.
More range, yep.
Okay,
Yep.
gotcha.
That's
Okay.
good.
And these basically are what electric cars were from about 1899 just about 1980. Just big, deep cycle lead acid batteries. Right?
Yes, yep.
What is that there?
That is a new line of battery packs Briggs & Stratton has come out with. It's a lithium-ion battery pack. 2 of these will replace the power output of one of those right now.
Right. And there's no fluids to change or anything in this?
Nope, no service.
Just says lithium-ion, okay. So each one of these basically is its own battery?
Yes.
And you start, okay, so.
We offer a 5 kilowatt hour battery pack that will eventually be used being used to power stationary equipment or
Right.
as our typical engines, the applications we power now. Anything that makes life easier or gets work done.
Because those give off ozone, correct? And you've got to make sure the water is filled, and they've got to be ventilated. So that could cause you some problems parked inside. Whereas this, everything is sealed.
Yes.
Okay.
And it's just so much more capacity for the size of it.
Right, right. Oh, cool. Well, that's fascinating. But it shows you we're still pretty primitive. Back in 1980 seems relatively, well, it seems relatively recent to me, but it's a long time ago. This is 40 years ago. But still, this is pretty much ahead of its time.
Yeah, the styling of it actually has held up pretty good.
Yeah. Well, the 6 wheels, I think, what gets everybody. You go,
yeah,
whoa,
it's
whoa,
interesting.
But now you explain why, because the other 2 wheels just carry the weight of the body. What is a vehicle like this? What does the whole vehicle weigh?
The whole thing weighs 3,200 pounds.
That's
isn't
all.
just too bad, yeah.
That's not too bad at all. And I imagine you must get excellent traction because you have about a 62% weight distribution here, something like that?
I did not drive it aggressively enough to find out the limits of traction.
We'll find out today when we take this baby to 150 miles an hour. What is the top speed, about 60?
68 miles per hour was done. Richard Petty drove it on a closed course.
Richard Petty, that's funny.
So
he must have been going, hello, hello.
Yeah.
68 miles an hour. And drum brakes all the way around, I imagine?
Actually, it has disc brakes in the front. Yeah.
Well, no, I think it's fascinating because, I think most people think Briggs and Stratton, little lawnmower engines and everything. It must be tough today building. Can you even still build air-cooled motors, even stationary motors now? Because those also have emission restrictions,
yeah, we
don't they?
started doing the emissions regulations in the early 90s, and there's been different phases, different levels, and we meet them. Yeah, I mean, we still make and sell a lot of internal combustion engines. There's a lot of stuff powered by that, but with this has kind of been the first thing we did, and now it's coming back. We're going into electrification.
Right.
The power equipment industry is going to electrification. The power levels that you're going to see electrification are much higher, getting into lawnmowers, tractors, and with our Vanguard lithium-ion battery pack, we can provide that power to those customers.
Now, that twin-cylinder engine, you said it's 18 horsepower,
yes.
Correct? But it looks like a torquey motor. Has it got some good low end to it?
Yeah, and that's typically how our applications are. It's more of a low end, low speed horsepower type thing.
I've got some parades, or parades as the French say. I'm not sure that's not how the French say it. But that's 850cc air cooled, and it makes about 57 horsepower. But it probably doesn't have the low end torque of this.
Big difference is our horsepower is rated at 3,600 RPM. By 3,800 RPM, this engine's topped out.
Right.
I would assume the engines you're talking about are at a lot higher RPM.
Oh yeah, easily 5,500.
Yeah, so your torque, your cylinder firing pressures, stuff like that's going to be similar, but they're just making it at a higher RPM to get that horsepower rating.
And how many miles have you guys put on this thing over the years? Do you know?
I think there's about 1,800 on the odometer, and I believe that was zeroed out.
Well, we're going to double that right now. Let's see what this baby can do. Should we drive electric first or gas first, or what do you think?
I guess it's up to you.
I'll tell you what, why don't we, since we're inside, why don't we electric out the door, and then we'll switch to the gas once we get on the road.
Okay.
That's right, Ollie. Let's do it. Here. Hop in. It's comfortable. Put the window down. Okay, so we'll start off electric.
Yep.
So the electric drive, pull knob to enable.
Yep, that'll enable your battery pack.
Okay, do I turn the key on?
You can pull that up first. Give it a good pull.
Up first.
It should latch. Give her a good pull into the latch. There you go.
Oh, there it is. Good pull. Turn the key or
Turn the key on.
Okay.
And you're ready to go. Pick a gear. With just electric, you don't even need to hold the clutch in. The motor's not turning at all.
Oh.
So you can let the clutch out and then just start giving it the gas. Right now, it's just like driving a regular car.
Suddenly, it's 1980. I mean, it actually cruises quite nicely. Yeah. And 60 miles seems amazing to me on lead acid.
With that battery technology, yeah, that's good. The more I've learned about this, and as we got this going again and seeing where the industry's gone, it's really made me appreciation for what this was and the concept behind it.
Yeah. And it doesn't feel that much heavier. Does Briggs & Stratton still make a lot of air-cooled motors, or mostly water-cooled now?
We don't make any water-cooled engines. It's always been a strictly an air-cooled engine manufacturer.
Yeah.
We have had some product lines with them, some engines that were water-cooled, but it's not a real high-volume, good business that fit us.
Well, let me ask you a technical question, because this is a question I get all the time. I have a Franklin, which is was the air-cooled car, 1915 Franklin. Two schools of thought. The thinner the oil you run in an air-cooled engine, the cooler it will run. Correct? You don't want to run a straight 50 weight in an air-cooled motor. Is that correct?
Well, I'm the kind of guy that says I need to see dyno tests. I need to see test data to make an answer on that. And the other part of it is most of the cooling comes from the fins in the air like that. But as for which oil gives you a little more cooling, I think the lighter stuff.
I think the lighter stuff because it's flowing.
Yeah.
And it can, I mean, a thicker oil will hold heat, correct?
Yeah, you get better thermal conductivity with the lighter grade oil.
Right.
As it touches the surfaces.
Because most guys I know run it's almost like water, the oil they run in the early Franklin. But it's one of those debates that people have back and forth, you know, Coke versus Pepsi, same thing.
Yeah, but the other side of it is the air-cooled engines typically run higher oil temperatures, so then you want the thicker grade for the higher oil temperatures. So it's kind of a trade-off, like everything.
Now, when I'm driving an electric like this, should I downshift?
Yes.
Okay. So I guess the idea being use electric around town, then when you get on the highway, you kill the electric?
Yeah, that's about the most efficient way.
Yeah. And what kind of mileage were they getting back in the day?
Back in the day, they were getting about 30 miles to the gallon on gasoline. That's 55 cruising, which 30 miles to the gallon back in that day was 200 or 300% better than a typical car was getting.
Right. Most cars are getting, 13, 14. Back on our gas engine, well, our gas and our electric, so we're using a combination of both to pull away. So when I shut off the gas engine, it sort of declutches, right? And
yes.
Goes strictly electric and vice versa. Okay. You guys are out of Milwaukee, correct?
Correct.
Now, Milwaukee's kind of like Modena in Italy. You got all these engineers, you got Harley Davidson, you got a lot of high-tech stuff. A lot of companies in that area.
A lot of engine manufacturing in that area. You've got the outboard marine business, the marine propulsion, Mercury, Evinrude.
So Briggs & Stratton's main business is still mostly air-cooled engines, right?
Well, we used to be known as a manufacturer of internal combustions, air-cooled engines, but now we've recently come out with our Vanguard Commercial Series lithium-ion battery packs.
Right.
So that the power equipment industry is moving towards more electrification.
Right.
And our engineering and our background has put us ahead in that field of getting into the electrification of those type of applications that we traditionally powered.
Always gas engine? You guys ever do diesel?
We did make some diesels in the early 70s. We actually make and sell quite a few engines for gaseous fuel, like liquid propane or natural gas. For home standby generators are powered by whatever the home has, natural gas or LP. So, and then our engines have to run on fuels from all over the world, and some of the fuels from other parts of the world are quite different and have unique needs for the engine. And we try to make a product that runs on all of them without making special products and stuff. And it's, again, answer the challenge of what seems to be a simple engine.
Were you guys on ethanol, for it or against it? Does it hurt?
Well, you don't really get for or against it. It's just something you got to be aware of, and you got to design your product for it. You know, when it was introduced, products that weren't designed for it, yeah, then it's going to cause us problems and expense. But the stuff that's designed for it is just fine with it.
And were there any other hybrids that you guys based this on at the time, or was this totally all original thinking?
It's totally all original thinking.
Because when I think back, I remember there were some electric cars back in the 80s. I think there was one called the T-Rex that would just show up at drag strips and just blow the doors off gas. And people were astounded.
Yeah.
It was unbelievable. You know, it just seemed crazy that an electric car could be so fast. But there really were no hybrids at that point. What's the most powerful engine Briggs & Stratton makes?
We're up to 40 horsepower right
Whoa!
now. Yeah. We have our Vanguard Commercial Series engines. And we recently came out with 40 horse versions of those, fuel injected.
Right.
And now we're working on electronic throttle, electronic governing on them. Very good product for us. It's actually referred as our big block engines.
Yeah.
We've commercially and internally, it's the Briggs big blocks.
Do you make any carburetors anymore? Is there any carbureted engines anymore?
A good majority of them are still carbureted.
Really? Yeah.
There's a lot of engines that don't have 12-volt systems that run without a battery.
Right.
So to have any kind of advanced electronics or fuel injection on is hard to do.
Right.
We do have one product with a fuel injection that's batteryless fuel injection, but it's
like
just
a magneto making electricity?
Yeah, the stator making the electricity to power it, but it's too complex and too expensive for a majority of our applications.
Now, is there a Mr. Briggs and a Mr. Stratton?
Well, Stephen Foster Briggs partnered with the Mr. Stratton for starting the company. He broke off. He wanted to do outboard engines. He started Outboard Marine or Evinrude Outboards.
Oh, okay.
So it's been the Stratton family pretty much the whole time.
Oh, okay. Now, were you surprised that we called, that we even knew about this thing? This thing hadn't been on the road. When was the last time it was out?
Probably like 1988.
Well, I mean, was it like, hey, Jay Leno called? How do you know? Was there that going on?
It was kind of a neat thing to hear from that you remembered or you knew about the car.
The fact that I remember it from 30 or 35 years ago, you know, it's like, oh, didn't Briggs & Stratton? Because, you know, a lot of times we always think that the Europeans and the Japanese are the first with an idea. And I think it's safe to say even a lot of the Prius engineering, I don't know how accurate Emmett is, but a lot of it came from General Motors, but nobody here was interested at the time because gas was still relatively cheap.
Correct.
When you went out and looked at it, it'd been in the warehouse for 30 years. It was like, oh boy, I got my work cut out for me. It seemed all right. What was the thinking?
Well, we actually have a museum that's pretty darn impressive, and it's been in our museum for the last 30 years. So I went to the museum and just started assessing the condition of it. Started with like the frame and structure of it, suspension. Then I started looking at the brakes or the car itself, and it looked pretty good. He said, hey, this is very possible. We pulled it out of the museum. We just started one thing at a time, starting going through and making the systems, make sure they're workable. And obviously the brakes, suspension, structural integrity was good. We got that all going. The engine I wasn't worried about. We're engine people, whatever conditions that's in. We'll get that going, but that didn't take much. And then the electronics, 72-volt electronics that haven't been turned on in 30 years. We did that kind of a step with a power supply. We slowly brought it up to voltage, monitored the components with infrared thermometer. Okay, nothing burned up, it's looking good, it's driving. Then we bought batteries and got that in, the new tires, and broke it out, and here we are.
There you go. And here we are. Well, thanks for bringing this thing along. See, it pays to think differently.
Yeah, yep, it does, and that's kind of how our philosophy at Briggs & Stratton. We do a lot of unique things, a big engineering staff that really has a lot of unique ideas and products for the
But I find if you think too different, then you get fired. So just think different enough.
Yeah,
that's it. And this is fun because this is really a one-of-a-kind car. It's the only one they ever built.
Correct.
Yeah. I never seen another one like it, so you don't have to worry about seeing yourself coming the other way, you know?
This is even exclusive compared to the McLaren F1.
That's right. This is more exclusive than the McLaren F1. They built 64 of those things. There's only one of these. Because there might be a reason they only built one. It only goes 68 miles an hour. But you don't get a speeding ticket. Well, Craig, thank you very much, my friend.
Well, thanks for featuring the car on the show. This has really been interesting for us to look back at and be a part of.
You know, it's a car I remember hearing about and seeing like 35 years ago, and like, wonder what ever happened. happened to that thing? It's nice to know they didn't crush it,
Yep.
you know, or destroy it.
Yep.
It's always fun to save history.
I tell you what, if you get to Milwaukee, you should come visit a company and
I would love to
see,
do that.
see our museum.
I'd love to see
really
the
neat museum.
Here we come, look at this. 60 miles an hour. Ah, a mile a minute.